Hello everyone, welcome to your next section. Today we are going to put everything that we've learned together from our statistics section and see if we can do some actual analysis. We're going to try and do a t-test and a linear regression. So this is going to be like your first time doing an actual statistical method design, like an actual analysis. We're going to do it on some test and demo data, but you're going to learn a lot of the foundational concepts, what to expect from these kinds of analysis and what the output is going to be like. So this is really just your first step. We're going to spend one class learning about basics of statistical analysis and then move right on to visualization. So you're learning one type of analysis, but there are so much more you need to learn as a data scientist. This is really where like data scientists become, this where data science is like you need to learn lots and lots of different stuff about it in your statistics. So we're just getting your feet wet here, showing you how to do a little bit of analysis in Python so that you can then go and explore all the other types of analysis that exist out there. So what we're going to learn today is we're going to learn about independent and dependent variables. These are going to be very important, especially with statistical analysis because of the terminology around it, but also it's also very useful for when you're doing visualization as well to understand what your IVs and DVs are and where they should be going on your axes. We're going to talk about this concept called the p-value. I'm not sure if you've ever heard of this before, guys, but this is a number that is used in a bunch of statistical methods. So it's important to understand what this thing is. It's a little bit abstract and vague sometimes, so we'll get into that. We're going to learn the student's t-test today. This is a way of comparing averages between two ordinal groups or nominal groups. And we're going to do a linear regression, which takes interval or ratio data from two things and tries to draw a line in between them and provide a statistical value of how close the relationship is between two sets of interval or ratio data given that straight line. Okay, so let's go into definitions. First, let's talk about IVs and DVs. An independent variable is usually in an experiment the variable that you control. You switch conditions on people where, some people are getting tested with loud noises around them and some people are getting tested with music around them. Those two different conditions, noise and music, would be your independent variable because it's the variable that you're manipulating and then seeing what the output of that manipulation is. The output of that manipulation is your dependent variable, the values that depend on your independent manipulation, okay? So usually independent variables are labeled on an x-axis on a graph, the horizontal line, and dependent variables are on the y-axis. Next, we have something called a student's t-test. This is a way to take results from two groups of people and determine if the averages of those two groups are significantly different from each other. Okay, so you can have two nominal groups like, vegetarians and meat eaters, boys and girls, you name it. They just need to be like nominal or ordinal groups. So we also have linear regression. So this is another method. It uses interval or ratio data and it compares how the spread of one set of data moves in tandem with another. So essentially what a linear regression does is it takes like a scatter plot, a plot with lots of points, and tries to draw a line in between all of those scatter points right in the middle, okay? And the more curved that line is, shows how much of the how effective the independent variable is on the dependent variable, and how close the dots are to that line shows to what degree we are certain that that relationship that we're trying to monitor is a straight line or a linear one. The last thing we're going to talk about is something called a p-value. I can spend a whole class trying to define what a p-value is for you guys. It's a very nebulous concept in many ways, so I'm going to try and give you the most practical, make sense thing I can. A p-value is the likelihood that your data is significantly different than from a normal population, meaning the data that you got, you have a certain degree of confidence that you didn't just get those results by chance or luck. Like if you wanted to say like two groups of people on average are different, but they were coming from the same population, there's a certain amount of likelihood that you just got lucky in who came to do your experiment, and that there isn't an effect at all. You just kind of like, almost like luck of the draw, got lots of people who scored higher. So the p-value is a number that says how likely that kind of scenario is. In a lot of soft sciences, like psychology or social sciences, the p-value needs to be something like 5%, 0.05 or less. But the hard sciences like physics, it's, orders of magnitude, 0.0000005. So that's what a p-value is, guys. They don't really call it a p-value in physics, but it's the same concept. So that's basically what a p-value is, though. With that, guys, we're going to spend a little bit of time on syntax. There's not much that you need to know on syntax, but I just want to talk about some things, and we're going to spend most of our time in terminal. Okay, so this is the code that we're going to be dealing with today, guys. We're initializing our two packages here, which is our we're going to load in something called SciPy, which is almost like an extension of the NumPy package. SciPy lets us do like our statistical analysis, our science Python kind of stuff. And then we're importing NumPy, or the random package in NumPy to do to just build some random values that we can do our analysis on. So we did something like this last class. Our first example, we're going to do a t-test. So we're going to create some random scores for boys and girls, and then we're going to see if there's a significant difference between them. If you remember how this function goes, we're saying we want numbers between 0 and 100 and 50 numbers, and like equal probability of any of them showing up. In this one, we're saying we want numbers between 40 and 100. So we would expect that this average is, pretty significantly different because, girls are not getting any lower than 40 on this example. So in order for us to do a t-test, we're calling SciPy. We're calling SciPy stats packages, and we're doing t-test_ind, and that means an independent samples t-test, meaning that this set of scores and this set of scores are from different people. They're not related to each other in any way. So we call independent samples t-test, and we give it the values for one of the sample 1 and sample 2, and this will give us some sort of output that we'll play with in a moment. The next thing we need to do is we're going to do a linear regression. So rather than talking about boys and girls, remember we are looking at interval or ratio data, so I'm comparing the amount of ice cream sales on a given day to the temperature. And we're going to see if we can create some sort of straight line linear regression that will tell us what the slope of that line is, how much of an effect it has. If this is a graph like this, we could say that if it's a flat line that there's no effect because even as temperature goes up, ice cream sales stay the same. With this, we're saying as temperature goes up, then maybe ice cream sales go up. But this will tell us to what degree. This going down this way might say that we get less ice cream sales as temperature goes up, which is interesting. We'll see what happens, though, in our analysis. It's going to give us it gives us the slope, it gives us the p-value, and it gives us a standard error, which is almost like our variance value. It also gives us our intercept. Remember, for like drawing lines in graphs in high school, in order to draw this line, you need mx plus b. The slope is m, whatever value here is x, and the intercept is b. Okay? So let's hop into Python now and actually start to play with this and see what happens. Okay, everyone, here we are in our terminal right now. We got to make sure that we install SciPy, so we're going to pip3 install SciPy. I have it already installed, so you guys might need to take a minute for this to download. Make sure you do let that happen. Pause this video if you need in order to get that downloaded, and then join us back here once we get into Python. So first thing we're going to need to do is we want to import SciPy, but in that syntax, I failed to mention that we actually need to call a specific package from SciPy. So we're going to go from SciPy import stats. Okay? And that's what's going to give us our t-test and linear regression functions. And then from NumPy, import random to get our random number generator. So first we wanted to see the difference between scores from girls and boys. So random.rand int. We did 0 or 100, size equals 50. Here we go, and we have girls, random, and I want these values to be different, so I'm setting their lowest to 40, which is much higher. So we should expect that there's a difference in these averages if we run our t-test. Next thing we're going to want to do is call our stats package, and we want to find that t-test independent samples thing. T-test independent, and we're going to go compare boys and girls. So what did this return to us? It says t-test results. It gives us a statistic. This is our t-value. So this is saying the t-value is negative 5.8, 5.38 roughly, and that our p-value was 5.08 with this negative 0.07 next to it. With the negative 0.07 next to it is saying that there are 7 zeros in front of this 5 here. So this is 0.0000000508. And that's what that p-value is. So remember from our previous class that in order for us to evaluate as something being significantly different in something like psychology, we need numbers less than 0.05. So this definitely has that going on. This has that value. So we can say that there is a significant difference between boys and girls, and this t-test is saying that boys are significantly worse than girls, which is what we would expect given we did this, we had the random number for girl generate at 40 and above. So we would definitely expect this to be significantly different. Okay, so next what we're going to do is we're going to change our example, and we're going to use, we're going to talk about temperature and ice cream sales, okay? And it's basically just going to be the same thing as before, but the context and what we're actually analyzing in terms of an example is going to be different, and that's important. So now we want to do stats.lin regression, and then we want to give it our x and y. So in this case, our x would be temperature, because that is what is modulating. That would be our independent variable that is influencing ice cream sales, or what we would expect to be influencing ice cream sales. And what do we get as a return? It gives us all of this information here. So remember in our example though, if we want to save all this information, it's slope, intercept, R value, P value, and standard error. And notice that because this is returning an object with many values, I can actually assign many variables all at once with just this one call. So I have that all there so we can see what's the slope, what's the slope of this linear regression? It's very flat. If the slope is 1, that means it's like up and down, and if it's 0, it's a flat line. So this is already telling us that this is probably not going to be significant because it's already like a very flat line. Let's look at p-value. P-value is way above 0.05, so this is not a significant test by any sense of the imagination. The intercept, meaning where this straight line crosses the y-axis, which is in our case ice cream sales, is at 70, so it stays pretty flat all the way across. And then our R value is something that maybe you'll spend a little bit of time learning about in your projects, but basically this R value tells you how much of the variance can be accounted for by our straight line that we've drawn. Okay guys, so what you've just done is you've learned how to conduct a t-test and a linear regression test and interpret some of those results using simple dummy data like temperature and ice cream, okay, with 50 data points in there. In our next section, in our next chapter too, actually, we're going to spend time visualizing our data. So now that we've done some sort of analysis, we might want to see what our picture looks like. We want to actually draw this line from our linear regression to show people visually, as opposed to with numbers, what we have been doing, what we have been kind of monitoring in our analytics. Okay guys, so I'm hoping that this opens your eyes to the types of tests that you can start to do in Python. There are hundreds of statistical analysis methods available out there. So read up, go on SciPy, read statistic test blogs, you name it. And this will seriously help you in your data science career. So let's just do a recap of what we learned today. We learned how to conduct a t-test. We learned what p-values are and how to interpret something like a t-test. We talked about independent variables, which are going to be even more important in our next chapter. And we also showed you how to conduct a linear regression, which is a type of test that uses ordinal or interval or ratio data as both from both the independent and dependent variable, as opposed to our independent variable being ordinal or nominal. So with that in mind, guys, thanks for listening and see you next chapter.